Hello everyone, I'm Christina and welcome to the fifth video in our A-Level Mathematics Calculus series. This is part 3 for differentiation from first principles. So we're just going straight into the second example from the previous video, and we want to work out the derivative of 2x cubed from first principles. So let's first recognize that our function f of x is 2x cubed. And we want to find its derivative, f dash of x. And the definition of our derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h, which we defined in our previous video. So now we want to calculate f of x plus h, as we already have our function here. So f of x plus h, we need to substitute x plus h into our original function. So x plus h will be our new input. So then our output will be 2 bracket x plus h cubed. So now we want to expand the brackets. We will have 3 brackets here because 2x plus h cubed is the same as 2x plus h, x plus h, x plus h. The easiest way to multiply this out is to first multiply out the first 2 brackets and then multiply the terms we get from that with the last x plus h bracket. So I'm not going to go through every step of the double bracket expansion because we did that in the previous video, so you can have a look back. But x plus h times x plus h gives us x squared plus 2xh plus h squared. And then, of course, we're going to multiply that by x plus h. So here, I will make it clear how we're doing this expansion. So it's the same as in the previous example, but of course now we have 3 terms in our first bracket. So we can see that here. So the first step is we take the first term of the first bracket, x squared, multiplied by the first term of the second bracket, and then we multiply that same term by the second term of the second bracket. And we do the exact same thing for each 3 of those terms. So for 2x plus 2xh, we multiply that by x, and then we take 2xh and multiply it by h. And then we do the same thing for the third term. We take h squared and multiply it by x, and then we take h squared and multiply it by h. So now let's write out all our terms. So we have 2, let's keep the 2 on the outside for a moment, and then inside our new bracket here, we'll have x squared times x, that's x cubed, x squared times h, that's plus x squared h. Then we have 2xh times x, that's plus 2x squared h. And then we have 2xh times h, that's plus 2xh squared. And then the final term in our first bracket, h squared, we then get h squared times x, that's plus h squared times x is also x h squared. And then we multiply our h squared by h, so our final term is plus 8 cubed. So let's try to simplify this a little bit before we multiply each term by the 2 we have in front there. So we keep that there. And if you notice, we have x squared h here and 2x squared h here. So that simplifies to 3x squared h. Then we have 2xh squared and xh squared. We can collect those terms as well to give us 3xh squared. And then the terms x cubed and h cubed remain unchanged. So now we can multiply each term by 2 So then we have 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed. So now this is our f of x plus h. So now let's use these functions for our derivative. So our derivative f dash x will be, again, the limit as h tends to 0 of f of x plus h, but we just worked out what f of x plus h is, so we'll use that expression. So 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed. So this is our f of x plus h. And by our definition, we are going to take away f of x. F of x is just 2x cubed. And that's all over h. So now we want to simplify the right-hand side a little bit. We want to look at our algebraic fraction here. And notice that this 2x cubed will disappear when we take away the 2x cubed here. So then we're left with f dash x, limit as h tends to 0, 6x squared h plus 6x h squared plus 2h cubed all over h. Notice that each term has the variable h, so we can factorize out h from the numerator and then divide through by h. So let's do that. F dash x, limit as h tends to 0, we get h on the outside, bracket 6x squared plus 6x h plus 2h squared all over h. As we noticed before, the h's cancel there. And then we can evaluate the expression that's left. So we have 6x squared plus 6xh plus 2h squared. We can see that as h tends to 0, the term 2h squared goes to 0 and 6xh also goes to 0. So if we evaluate this limit, we are actually left with 6x squared. And that is our derivative. So to summarize, for the function f of x equals 2x cubed, its derivative f dash x is 6x squared from first principles. Okay, so in the next video, we're going to look at differentiating a few trig functions using first principles.